Remember that word from grade 10? Well, what did we have the last days? We had a linear inequality. So a system means more than one, i.e. 2. Are we getting 3? I can't remember. We might. You might. System just means more than one, so it's pretty much the same stuff. Okay? You just got 2 of them on the same graph. So let's write it in the same weird form that the book does. Graph the system showing the solution set. Well, that's what you've been doing. Remember? So don't do this, but so we do a line, might be dashed, might be solid, okay? And it's a line, guys. I saw this on some quizzes. Does it just stop right there? No, it doesn't. It goes like that. There's actually arrowheads on here. It goes forever and ever and ever. Then we find the solution. In other words, we do a test point. 0, 0. Didn't work. That's my solution set. That assumes it's all real. If it's whole numbers, then I'm gonna do that. Okay? Actually, no, I'm not gonna do that. If it's whole numbers, I'm just gonna do that. If it's integers, I'm gonna do that. Okay? But I'm showing the solution set. We're doing the same thing, but now we got 2. So the book will say x, y, such that 3y minus x is less than 6 plus x, where x is all real and y is all real numbers. Now, I got another one. Let's use a different color. If you got a different color, use it. It's easier to figure out which one's which. Y is less than or equal to x, where x is all real, and y belongs to the set of all real numbers. That's what that thing says, right? Greek letter E stands for epsilon.
They actually had that on Jeopardy.
Did they?
Yeah, there was the longest letter.
Well, we have 26 letters. In Greece, they only have 24. First letter you got in math, Greek letter, was before alpha. You got this in grade 7. Pi, right? The whole list is like I got it on the wall there, I got it on the wall over here. Okay, you've seen in science, you've seen alpha, you've seen, not psi, gamma. What the heck, I can't remember what gamma looks like. Anyway, have you seen that one? Change in, delta, yeah. Okay, there's lots of them. If you take science in university, you go basically through the whole Greek alphabet. And if you join a fraternity, Phi Delta Kappa, because they're all named after Greek letters, then you'll have that for symbols on like bracelets and necklaces, and it'll be on the front door of the frat, okay? And when you're old enough, it's a place you go and drink beer, among other things. Okay, so we got to graph this system. Here's my graph. These go forever and ever and ever. X, Y, we know that. So the first one, here it is. That's all I'm worried about, okay? This, ignore it. It's just there to confuse you. I know it's X and Y. And then I got to go back and look at this stuff, real, to see how I'm going to graph this thing. So we're going to start with that. I'm just going to get the boundary line, so just ignore the inequality. Just pretend it's equal. That we saw in grade 10, maybe even grade 9, if you guys had a good teacher. Can I make this a little nicer? If you got like 10 different numbers here, make it one number. If you have 16 different y's, just make it one y. Collect your like terms. That's what I'm saying. Do I have more than one y? No. More than one number? No. But I got a couple x's, don't I? Collect them. What side do you want them on? Doesn't matter. It doesn't. Algebraically, when we get our x and a y or intercept, we're going to get the same thing. So it doesn't matter what side, but let's make them positive. Okay, whatever you do to one side, get rid of it. You do to the other side. So 3y is 6 and what's x and x? How many x's do I have, Chelsea? Thanks, Chelsea. Okay, that's as nice and clean as I can make it. This makes it easier when I'm getting my 2 points to graph the line. And the 2 points I want are x-intercept. What happens at the x-intercept? Y is 0. Always, always, always. Substitute it in there and solve it for x. That's 0. How do I solve that thing for x? Want to get rid of plus 6. Subtract it from both sides. Negative 6 is 2x. Divide by 2. X-intercept is negative 3. What's the coordinate point I want to plot? That says that coordinate point, right? Because it is the x-intercept. That's where it crosses the x-axis. So that is right there. Got 1 point, just need one more, and I can graph this line. What's the other point I want? The y-intercept. That's where x is 0. Write that, people, so you know what you're doing. If x is 0, I'm going to substitute that in the equation right there. You're tardy. All right, so 3y is 6. Divide by 3, and that is the y-intercept at 2. As a coordinate point, it's 0, 2. X is 0, y is 2. That's right there. So I know where my boundary line is. Do I want to make it solid or dashed?
Yeah.
Yes. Why, Kylie?
Because there's no line.
Yeah, because it's just less than, not less than or equal to. So, as straight as I can, and it goes forever and ever and ever. Okay, guys, we don't just go from there to there, like some of you did on the quiz. Okay, you do the whole line. Even if it is whole numbers, you still want the boundary line there. You're just going to shade that part, or dot that part, or whatever, okay? And if for some reason it's this part, you do that part. But we still want to see the whole line. Okay? Now, what side do I shade? I don't know. How do we do this? Yeah, let's test a point. Could I test this point? Absolutely. Right? I can clearly see that it's on one side of this line or the other. So put that back in the original equation, like, what if I made a mistake with my algebra? Then this guy's wrong, right? Put it right back in here. And besides, that has an equal sign. I need to know the equality. So test it back in the original equation. So 3 times 0 minus 0, is that less than equal to 6 plus 0? 0 minus 0, that's still 0. Is that less than 6? Okay. Yes. So what does that mean? It means this point is a solution. It worked. This is a solution. So I want to shade, because it's all real, wherever that 0, 0 was. Okay, so now I'm going to be systematic about this, and you'll see why in a sec. Go horizontal with your shading. You will see why. I got another line going on here, right? I'm only half done. This is a system. Still got this guy to do. Okay? So that's where 6.1 stopped. That was on your quiz. Not the exact same question, but 2 times, right? Can you do that? It was 3 marks, by the way. Did you all notice that? Show work. This is good work. There's a mark, there's a mark. It's dashed. That means I'm understanding this. There's at least half a mark. I shaded the right side. There's a mark. Okay? So, that's all this guy. Now I got this one. I'm gonna try to stick that under here. Right down here. Okay, so again, ignore the inequality. I want to know where that line is. Hold that thought. How do I do that? I find the x and a y-intercept. Yeah, something weird's going to happen here. What happens at the x-intercept? Y is 0. Substitute it in there. 0 equals x. And what's that? That's the x-intercept. So the coordinate then, that's x, but y is 0 too. Huh. That's right there. What happens when I get the y-intercept? What happens at the y-intercept? X is 0. Plug it in here. 0 is y, and I get the same thing. I need 2 points to do a line. That's only 1 point. This is the same point. So now what do I do? You got a couple of options. Let's plot this thing and see what happens. You started doing this stuff in grade 8, right? If x is -1, what's y? Yeah, x is y. Y is x. If x is 0, what's y? I already got that point. Let's plot -1 and -1. All I need is 2 points, right? Got my 2 points. Let's just plot a couple more, because I don't know if you guys are familiar with this or not. If x is 1, what's y? 1. Common sense. Y is x. Whatever x is, that's what y is. If x is 2, y is 2. If x is 10, y is 10. Where is that? That's way over here somewhere. If x is -3, y is -3. Do you see what this thing looks like? So that's one way to think about it. What's the other way? Let's put it in y equals mx plus b form. This is y equals, what must the slope be here? What's the number in front of this x? Yeah, 1, x, and what must b be? There's nothing there, so b's got to be 0. So that's another way to think about it. My y-intercept is 0, right there. I already knew that. And then my slope, I go up 1. That's the rise. My run is 1. And 1 and 1, I get the same thing. So that's my line. See, it's harder because it's easier, right? There's less stuff here. That's why you guys, people get that and they go, well, I don't know what to do now. I don't have all these extra numbers in here. I don't know where that line is. You'll all be using one of these soon, but if you do have one now, you can graph this. Go up to y equals, y is x, hit graph, and does that kind of look like this line? Sure does. It's a 45-degree angle right at the origin. Why did I do it solid? Because it's less than or equal to. Okay? So that's my boundary line. Then all I got to do is find out what side to shade. Can I use 0, 0 for a test point? No, because that's right on the line. I know that's a solution. I got to use something else. What point do you want to use? It doesn't matter. I could use that point. I could use this point. I could use this point. I could use that point. How about that guy right there? What's the coordinates of that point? 1, -1. Okay? So y is less than or equal to x. Y is -1. Is that less than or equal to 1? Is -1 less than 1? Sure is. So that's in the solution area for the blue line. So I want to shade that in a different direction so the teacher knows I know what the heck's going on here. Because if it's in the same direction, it's kind of hard to see what's going on. Okay? That is the solution set for the two lines. So where is the solution set? That's where it's shaded in both places. So this isn't the solution set for the two lines. That's just for the one line, right? So this is both lines. All this. And not there. Okay? That's the solution set. Where it works for both lines. Where they cross. So again, it's kind of the same stuff, only you just got two lines. And I'll show you that weird guy. So half of the assignment is that. Okay? There's another question on page 317. I'll give you that on Tuesday. And that's pretty much it, guys, for this chapter. That's pretty much as we're going to do. Just some word problems.
It does say
It does, eh? Okay, I'll fix it. That's not what I want. Whoop.